Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a great, quick and relaxing algebra question. We know that the sum a plus b equal to 16 and the product a times b equal to 20. So we need to solve this question for a and b. So if you have your solution, your answer, you can also write it in the comments below and then we will check our answer. So write your solution and then we will check it. Okay, so first of all, what is the main idea? First of all, let's express from first equation, let's express b. This is our first step. So every time you have system of equations, every time express something. In our case, let's express b. So b equal to 16 minus a. 16 minus a. And right now let's plug in, instead of this b, let's plug in 16 minus a into this second equation. So let's do it right now. So we have a times 16 minus a equal to 20. Right now, let's simplify it. We have only one variable, we have only a, so it's really good. Let's multiply this a by this parenthesis. So we have 16a minus a square, and let's write this 20 on the left side. Let's do it. So we have minus 20 equal to 0. And right now we have, looks like this is a quadratic equation. Here we have square, we have a, we have constant, but we need to reorder this. So we need to change this order real quick. First of all, let's write this minus a square on the first position. So minus a square on the first position, plus 16a on the second position, this coefficient, and minus 20 equal to 0. And the final tricky move. I recommend you multiply both sides by minus 1. A lot of students might be thinking that this is not necessary, but I prefer solving this quadratic equation with the basic order of signs. So that's why I don't need this negative sign right here. And then I have a classic order. So a square without negative sign with a positive. And right here we need to change all the signs. So minus 16a plus 20 equal to 0. Okay, so this is our first step. So we really hope you understand how can we get this quadratic equation. What are we going to do next? Right now, let's solve this quadratic equation. Of course, there are a lot of ways how can we do this, but maybe the basic one is basic of method of coefficients. So that's why let's write our coefficient a equal to 1, our b equal to, this our second coefficient equal to minus 16, and our third coefficient c equal to 20. And right now let's solve this quadratic equation. First of all, I'm gonna solve it for a discriminant. So b squared minus 4ac equal to, so b squared, so minus 16 square minus 4 times a times 1 and times c times 20. So right now let's simplify it. So we plug in each of these elements into this spot. Let's do it. So what we're going to do next? Minus 16 square equal to 256. This is our table case. Minus 4 times 20 equal to 80. So equal to 176. So the first new is that our discriminant is greater than 0. It's also really good. So right here we have two real number roots. If you wanna say more, okay, two real number roots. So right now let's solve it for this root. So a first and a second. So minus b, this is a classic formula, plus minus square root of discriminant, and all over to a. Okay, so minus b minus 16 plus minus square root of discriminant, square root of 176, and all over to a, 2 times 1. Okay, so let's simplify it. So minus 16 equal to 16, so 16 plus minus square root of 176. How can we express this 176? The best way to do it is to write it as 16 times 11. Okay, this is equal to 176 and all over 2. Why do I choose this 16 times 11, not like another way? Because square root of 16 equal to 4, and so this is our table case. That's why we express this square root of 176 as a product of two values. One of these should be like table case, yeah? So we have 16 plus minus square root of 16. So according to a square root property, we can split it like square root of 16 times square root of 11. So a square root of a product equal to product of square roots over 2. So we have 16 plus minus 4 square root of 11 over 2 And our final step, let's factor our 2 from our numerator. Yeah, so let's plug in it, let's factor it. So 2 in parentheses, we have 8 plus minus 2 square root of 11, 2 square root of 11, and all over 2. So as a result, our answer is 8 plus minus 2 square root of 11. This is our a first and a second. So let's write it. So a first with the positive sign right here, with the positive sign, equal to 8 plus 2 square root of 11, and a second with a negative sign equal to 8 minus 2 square root of 11. This is not our solution. This is only a first and a second, but in the beginning we had that our b equal to 16 minus a. So that's why we need to solve it for b first and for b second. So that's why b first equal to 16 minus a first. So 16 minus a first, and right here equal to 16 minus a second. So let's plug in it. So b first equal to 16 minus 8 plus 2 square root of 11. So b first equal to 16 minus 8 minus 2 square root of 11. So b first from here equal to, right here we have 8 minus 2 square root of 11. Yeah, and according to the same logic, b second equal to 16 minus a second, 8 minus 2 square root of 11. Let's simplify this real quick. So b second equal to 16 minus 8 plus 2 square root of 11, and our b second equal to 8 plus 2 square root of 11. One really interesting pattern we can see. Yeah, we have 8, we have the same, absolutely the same constant, but different signs. Yeah, we have 8 plus 2 square root of 11. We have plus, right here we have minus, right here we have minus, right here we have plus. So we have, looks like symmetrical pairs. So let's write our final answer, and then we will check it. Okay, so our answer. So 8 plus 2 square root of 11 and 8 minus 2 square root of 11. This is our first pair, and the second pair, 8 minus 2 square root of 11 and 8 plus 2 square root of 11. Okay, really great. And in the end, let's check real quick, let's prove real quick our roots. So a plus b, our system of equations looks like that. So a plus b equal to 16 and ab equal to 20. Okay, really great. And right now let's check. One really interesting hint, one really interesting moment. We have right here addition and multiplication. And a plus b equal to the same as b plus a. So right here we have symmetrical roots, so it doesn't matter. We can check only one pair of roots. We don't need to check both of these because we will have the same answer because of this addition. So we can change these a and b by places. So a plus b equal to b plus a. We have symmetrical roots, so it doesn't matter. In our case, let's check, for example, addition of these two elements. So a plus b equal to 8 plus 2 square root of 11 plus 8 minus 2 square root of 11 equal to 16. Let's check it. So it's great because right here we can cancel it. So 8 plus 8 equal to 16. So addition is great. And of course you can also check this one, but we will have absolutely the same thing. You can easily see it without this thing right here. 8 minus this one, 8 plus this one. So we can cancel this. We will have absolutely the same thing. And multiplication is absolutely the same thing as addition because a times b equal to b times a. So that's why we don't need to check both of these because we can change places right here. So we don't need to check both of these. We will have absolutely the same root because of multiplication. It works perfectly with addition and multiplication, not with subtraction and division. Yeah. So a times b equal to 8 plus 2 square root of 11 and 8 minus 2 square root of 11. And a lot of students might be thinking, okay, we need to multiply parentheses by parentheses, but just look at this closely. 8 plus something, 8 minus something. So x plus y, x minus y. We can easily change it by x plus y. So in our head, yeah, x plus y and x minus y. Isn't it like a formula from school, our classic identity, ax squared minus y squared? So difference of squares, yeah, it is. This is our formula from, this is our school formula, x squared minus y squared. So difference of squares. First element square, 8 square, minus 2 square root of 11 square. We raise this to the second power. And right now, 64 minus, what do we have right here? 2 squares, we need to raise this 2 to the power 2 and this one. So right here we have 4, 2 squared 4, and square root of 11 to the power 2. We're going to cancel this square root sign, so we have only 11. 4 times 11 equal to 44. So equal to 20. And we have this, a times b equal to 20, so an expression that we exactly need. So our root is absolutely great. This is our answer, so I don't have enough space, so that's why I'm going to leave our answer right here. So we have 2 pairs of roots. This is the first one, this is the second one. Both are correct. So thank you for your time. Have a great day. Also write your thoughts, write your response in the comments below. It will be really interesting to read about it. Write your notes, write your question. What do you think about this type of question in the comments below? It will be really interesting to read about it. Wish you all the best in life. Take care of yourself. Have a great day. See you in the next videos.